Welcome to this tutorial on cross correlation in signal processing. In this video, we will break down the concept of correlation, explain its mathematical representation, and explore the difference between autocorrelation and cross correlation. Let's dive in. Let's understand what correlation means. In signal processing, correlation is a measure of similarity between two signals that vary over time or space. Mathematically, if we have two real valued signals, x of t and y of t, the correlation between them is represented as r of xy tau equal to integral function of minus infinity to plus infinity x of t dot y of t minus dot dt. Here, r of x, y, tau tell us how much x of t and time shifted version of yt are aligned with each other. The correlation coefficient r of x, y of tau measure the similarity between xt and time shifted signal y of t minus tau. The variable tau represents the temporal distance or the amount of time shift between the two signals. By analyzing r of xy tau, we can understand how these signals relate to each other over time. To make it clearer, let's look at graphical representation. Here we have a signal x of t observed at a time t equal to minus 0.35, t is equal to 0 and t is equal to 0.35. We also have y of t, which is a time shifted version of xt. By calculating r of xy tau, we get a new correlation signal that describes the similarity between xt and y of t minus tau at every time step. Now, there are two types of correlation, autocorrelation, cross correlation. Let's start by understanding autocorrelation. Autocorrelation measures the similarity of a signal with its own time delayed version. It gives us insights into repeating patterns or periodicity within the signal. Mathematically, it is expressed as r of 1 tau is equal to integral of minus infinity to plus infinity x of t dot x dash of x dash of t minus tau dt. If we shift x of t by tau units in the negative direction, then autocorrelation becomes r of 1 tau is equal to integral of minus infinity to plus infinity x of t plus tau dot x dash of t dt. This is a powerful tool for analyzing signal stability or periodicity. Now let's move to cross correlation. Unlike autocorrelation, cross correlation measures the similarity between two different signals and their time delayed versions. For two signals x1t and x2 of t, cross correlation is defined as r of 1 to tau is equal to integral of minus infinity to plus infinity x1 of t dot x2 of t minus tau dt. Again, if we shift x1 of t by tau units in the negative direction, the formula becomes r of 1 to tau is equal to integral of minus infinity to plus infinity x1 t plus r t plus tau dot x2 of t dt. Cross correlation is extremely useful in finding the alignment or delay between two signals, such as in communication system or pattern matching. To sum up, both autocorrelation and cross correlation help us understand the relationship between signals, whether it is with themselves or with others. These concepts are fundamental in fields like signal processing, data analysis, and even machine learning. Thanks for watching. If you found this explanation helpful, don't forget to like, share, and subscribe for more tutorials.